Okay. So even I and J are as column of the different definitions are there. So the definitions are row or okay, order of the matrix we have. Order of the matrix is this is M cross M. So next we have what is the square matrix and what is a rectangular matrix. Okay. Next row matrix. Row matrix also I have told only if one single row is there, then we call it as a row matrix. That is like this A, B, C. This is called as row matrix. Sorry, this is the column matrix and row means 1, 2, 3. So this is the row matrix. This is the row, this is the column matrix. Only if single row is there, then we call it as row matrix. If single column is there, then we call it as a column matrix. Okay, zero or null matrix. If in place of whatever the elements are there, 0, 0 is there, means we call it as a null matrix or zero matrix. Okay. And also principal diagonal of a matrix will be there. Principal diagonal means, so any 3 by 3 matrix, it will take 1, 2, these are definitions you have in your textbook. So like this, if any C is any matrix, so it is 3 by 3. Okay. So principal diagonal means from first element of first row to last element of the last row. So this is called as principal diagonal matrix. Only principal diagonal we will take for only for the square matrix. Why? Because in that only we'll get the correct elements. No. So 1, this is the second element in the second row and third element in the third row. So this is called as a principal diagonal of a square matrix. Only diagonal matrix will be also there. Only diagonal matrix means here whatever the principal diagonal is there, that you will have some elements and other elements will be 0. Like this. Whatever principal diagonal is there, principal diagonal you will have elements, and whatever the remaining elements are there, those elements if you have having the 0, then it is called as only diagonal matrix. Okay. And even if you have these whatever this principal diagonal is there, if you have all ones, we call it as a unit matrix. So that will be the difference. And one more matrix is a scalar matrix is there. Scalar matrix means this is the principal diagonal. Principal diagonal matrix. This is the diagonal matrix. And one more is scalar matrix. Scalar matrix means, so instead of here you have different elements. So if you have same elements, that is here 2, 2, 2, then we call it as a scalar matrix. That means we can take 2 outside and we can write it as 1, 0, 0, 0, 1, 0, 0, 0, 1. So something of some multiplication, some quotient of the identity matrix. Or else if you have not the identity matrix, okay, this is the identity matrix. All are unit elements. 1, 1, 1 is there. The here 2, 2, 2 or 3, 3, 3, 4, 4, 4 are A, B, A, small a, small a, small a, like that. Any the element which is first element of the first row, second element of the second row, third element of the third row. If you have the same element, then we call it as a scalar matrix. And if you have here different elements, then we call it as a diagonal matrix. And if here only whatever the elements are there, that we call it as a principal diagonal matrix. Okay. So in textbook, you have the definitions once you see those definitions. But here the unit matrix is the important one. We call it as a unit matrix, or that is identity matrix. Identity or unit. Okay. So this if will represent as A, this is 3 by 3 unit matrix. And if it is a 2 by 2 means 1, 0, 0, 1. Okay, 2 by 2. And compulsory identity matrix will be only square matrix only. Okay. So this is the important one. Almost will in the problems we'll get that one. And one more important one is transpose of a matrix. So if we'll take this matrix, C is there, no? C is there. So if we'll write transpose of this matrix, that means we'll represent C to the power of T. Okay. Transpose of a matrix. Transpose of a matrix means nothing but just interchange of this is first row, this is second row, and this is the third row. You have to write first row as first column, that is 1, 2, 3. Next second row, that is 4, 5, 6. Next third row, 7, 8, 9. Okay. So just interchange of these rows by columns is called as a transpose of a matrix. That is the definition of the transpose of a matrix. Okay. So this is also important, transpose of the matrix. In solving the problems, we will use this concept. Next, any matrix is given means like this, you can do the transpose of that matrix. Next, equality of two matrices means two matrices are equal if and only if they are of the same order and their corresponding elements are equal. So here, if you take any small matrix, only 2 by 2, 1, 2, 3, 4 is there. And one more matrix is there. This is also if you have 1, 2, 3, 4. Here also order 2 by 2. Here also order 2 by 2. Order should be same and also numbers. Whatever the elements are there, if the elements are also same, then we call A is equals to B. That is matrix A is equals to matrix B. That satisfies the equality of the two matrices. Okay. So next, by comparing any two matrices, you have to see whether the given matrices are equal, means they are equal or not, means one example problem you have in your textbook. If A equals to XY PQ equals to this, find XY P and Q values. Means both are equal, it is given in the question. That means when both are equal, means the element should be equal. Just for your understanding, this one I am telling, it is in the example you have. If A equals to like this, if A equals to XY PQ, it is equals to 0, 1, 2, 3. Okay, then find X comma Y comma P comma Q. So in between equal symbol is there. Equal symbol is there means this matrix is equals to this matrix, and also whatever the elements are there, those elements are also equal. So X equals to 0, Y equals to 1, P equals to 2, Q equals to 3. Okay. So that means when they are equal means the elements are also equal. So in the solution you can write, we can write that since the two matrices are equal, their corresponding elements should be equal. Therefore, X equals to 0, Y equals to 1, P equals to 2, Q equals to 3. In between, write that sentence. That is, since two matrices are equal, their corresponding means the place of this element and this element. This is called as corresponding elements. First row, first element. Here also first row, first element. First row, second element. First row, second element. These are called as corresponding elements. The place where they are existing, those are called as corresponding elements. Okay. So this is the concept we have. And after that, if like this problems also solving will be there. One more example problem is there in this only concept. If A plus B 0, 0, A minus B is equals to 7, 0, 0, 1. Okay. Then find A and B values. This also equal symbol is there. Then find A comma B. Okay. So here also same sentence you have to write. Since the two matrices are equal, okay, so their corresponding elements must be equal. So when their corresponding elements are equal means corresponding element here A plus B is there, it is equals to 7. That is A plus B equals to 7. Here 0 is there, 0. We need A and B values. Here also 0, 0. Next one what we have? A minus B equals to 1. Okay. We got here two equations. That is A plus B is equals to 7 and also A minus B equals to 1. So if you solve these two, what will happen? You can take this as 1 and this as second equation. Okay. So solving 1 and 2, we get that is A plus B equals to 7, A minus B equals to 1. Okay. Or else you can write adding 1 and 2 or solving 1 and 2. So here you are adding this one. So when you are adding, no need of changing the signs. So if you cancel these two, so what will be remain? Plus B and minus B both are cancelled. So this is A plus A is 2A. 2A is equals to 7 plus 1 is 8. Implies A is equals to 8 by 2. No? So you will get the value as 4. So A we got 4. If you substitute here, what you will get? B value as 3. 4 plus B equals to 7. B is equals to 7 minus 4. Substitute A in 1. So what will happen? A value is 4. 4 plus B equals to 7 implies B is equals to 7 minus 4 equals to 3. Okay. So like this, even you can solve the here directly the elements were there. So you have written the values. But here it has given in place of that element A plus B and A minus B. So when you equate these two corresponding elements, you will get the A and B values. Okay. So this is also simpler. You will get for the 5 marks questions. And next we have the concept of the symmetric matrix is there. Symmetric matrix means just if a matrix is equal to its transpose, means matrix A and its transpose, both if the values are same, then we call it as a symmetric matrix. So on this also exercise, you are not having any problems. And also next we have addition of matrices or subtraction of two matrices. Okay. Addition or subtraction of two matrices is possible only when they have the same order. Okay. So if they have 2 by 2 order or if they have 3 by 3 order, that means a square matrix can also only square matrix means rows and columns are equal. Okay. So for a square matrix, only the addition or subtraction is possible. Why? Because addition means adding of the corresponding elements. Whatever, if here one element is there, here you for that element you will add that one, or you will do the subtraction. So that's why if they have the same order, then only the addition or subtraction of the matrices will be possible. Okay. So that is about the addition of two matrices. So addition of even three matrices also we can see if A, B, C are given. So you can find A plus B, B plus C, C plus A, like that, any elements. Okay. Addition of matrices will be even commutative property will be also there. Okay. So if A is like this, any matrix 0, 1, 2, 0 is there, and B is 3, 4, 5, 6. Okay. Then find A plus B. Okay. So A plus B means A plus B is equals to, first you write this one 0, 1, 0, 2, 0. B means 3, 4, 5, 6. So it is equals to corresponding elements. See, first you write like this if you have any confusion. 0 plus 3 next 1 plus 4, next 2 plus 5, next 0 plus 6. So what you will get? 0 plus 3 means 3, 4 plus 1 is 5, 2 plus 5 is 7, 0 plus 6 is 6. Okay. So even for this, we can find B plus A. B plus A is equals to, just B here you write 3, 4, 5, 6 and plus 0, 1, 2, 0. You'll get same elements, no? Just you have interchanged that one, B here and A. So you'll get both 3, 5, 7, 6. I'm writing direct that one. So what we have observed, A plus B is equals to B plus A. Okay. So if you have, remember the sets and relations in 10th and 9th class you have. So that is, if properties you have, no, closure property, associative property, commutative property, and identity property, inverse properties will be there. So if you have idea, just you recall that, or else if addition of A plus B is equals to B plus A, just inverse of this one. If these two are satisfied, we call it as a commutative property. Commutative. Why? Because A plus B and the interchange of second matrix plus first matrix also, you got both same values. Then we call that it is satisfying the commutative property. Okay. So A plus B in addition, it will satisfy, but in the multiplication, that is multiplication means AB. In some cases, it may or may not equal. Okay. AB may not be equal to BA. You can verify that one by doing the multiplication. Okay. So addition is very simple in matrices, but multiplication is somewhat complicated one. And you have to remember one rule will be there for the multiplication of the matrix. Okay. If you remember that rule, then only you can multiply the two matrices. Okay. We call it as a multiplication of the matrices or the product of the two matrices. So multiplication of the matrices, for that the condition is, that is a number of columns in A matrix. First matrix will be there, no? In the first matrix, if the number of columns in A is equal to the number of rows in B, we can multiply the two matrices. Okay. Here addition only for the two if they have the same, that is a square matrix, or if both are rectangular matrix. Even if here rectangular matrix is there, no? So if C is one more rectangular matrix, then you can do the addition. Okay. So addition is not only for the square matrix, for the rectangular matrix also will do. But the order, whatever it is there, 2 by 3 means another one should also be 2 by 3. Okay. So two rectangular matrices also you can add. Why? Because here corresponding element, they also will have the same one. Okay. So, but here order is very important. It should have both should have the same orders. But in the multiplication of the matrices, the condition is that whatever the first matrices is there, in that number of columns, if you see here, this is first column and this is the second column you have. Number of columns in the first matrix should be equal to the number of rows in the second matrix. So your two columns are there. Here how many rows are there? 2 rows are there. So we can multiply these two. Why? Here also you can represent. This is row and this is column. No, that is this one and this one. If both these two are same, then we can multiply. Because this is a 2 by 2. This is a square matrix and this is the rectangular matrix. Both are not same matrices. No. This is the square matrix. This is the rectangular matrix. But we can do the multiplication. But we can't do the addition or subtraction. Why? Because here one more row is not there. One more column is not there here. Okay. So that is the difference between addition and multiplication of the two matrices. And remember the condition, number of columns. This is row, this is column. So number of columns in the first matrix should be equal to the number of rows. Here number of rows are 2. So 2 and 2 both are same means we can do the multiplication of the matrices. Okay. So that is a very important one. Not only this problem, many problems if you have in your any exercise or anywhere, this condition is applicable for that. If that condition is not satisfied, then we can't multiply the two matrices. And remember that one. Such type of examples also will be there. By seeing the first condition, you have to check this one. First, you write the order of the given matrices. If column is equal to the row, then only you can do the multiplication. If these two are not same, then you can write in the answer that since the number of columns in the first matrix is not equal to the number of rows in the second matrix, so the multiplication is not possible. You can write directly. Okay. So like that examples also you may have in your example problems in the textbook. You can see that one. And if you see the matter in the exercise, you have one problem is there. That is find the product of the matrices. Find the product of the matrices. Find the product of the matrices. A equals to 1, 2. And B is equals to 0, minus 2, 3, 1, minus 1, minus 3. Okay, these are the two given matrices. Then we have to find the product of these two matrices. Okay, first you see what is the order of this one. This is the square matrix, so it is a 2 by 2 matrix. And here for the B matrix, first 1 row, 2 row, and 1, 2, 3. 3 columns are there. So 2 rows and 3 columns. Okay. So here same whatever we have, that only we got. Here number of columns are 2, and here number of rows are 2. So multiplication of these two matrices is possible now. So now we can find the multiplication of this one. So we will write AB as A. First you write matrix A 2, 1. And then you write matrix B 0, minus 2, 3, 1, minus 1, minus 3. Okay. So this is equals to, how you have to do the multiplication means whatever the first row is there. First array. So first element of this one into this multiplication, next second element of first row into this one. So this into this, again first row, second column, next again first row, third column. Okay. Similarly, second row, first column, second row, second column, second row, third column. Okay. So first I am writing here see. So 1 into 0. Okay, plus 2 into 1. Okay, this is first row, first column. Next, first row, this second column. That is 1 into minus 1 plus 2 into minus 1. If you want, you can write in the brackets also like this. 2 into minus 1. Negative sign is there, means there you can write brackets if you have any confusion. Next, first row and third column. So third column is 1 into 3 plus 2 into minus 3. Okay. Next, second row, same. First column, second column, third column. That is 2 into 0 plus 1 into 1. Next, 2 into minus 2 plus 1 into minus 1. Okay. Next, 2 into 3 plus 1 into minus 3. And here you remember this, whenever here number of columns and number of rows, when these two, whatever common are there, if they are eliminated, then whatever the matrix you will get, that will be the order 2 by 3. So same 2, 2, if you get cancel, what is remaining? 2 is remaining here, and what you have here? 3. So if you have done any mistake, you can rectify that one. You should get 2 rows and 3 columns in the answer. Okay. So it is equals to 1 into 0 is 0 plus 2 into 1 is 2. So 1 into minus 2 is minus 2 and this is minus 2. Okay. 1 into 3 is 3. 2 into minus 3 is minus 6. Okay. 2 into 0 is 0. 0 plus 1 is 1. 2 into minus 2 is 4. Minus 1. 2 into 3 is 6. And this is minus 3. So it is equals to 2. Minus 2 is minus 4. 3 minus 6 is minus 3. 1 minus 5. And 6 minus 3 is 3. See how many rows we got? This is first row. This is the second row. 2 rows. And 1, 2, 3. 3 columns. So when you eliminate the common in this, whatever remaining is there, 2 rows and 3 columns. The order of the resultant matrix, whatever we got, that is 2 by 3 matrix. Okay. So like this, you have to find the multiplication of matrix. Square matrix also you can do. Or same, if the rectangular matrix is there. In that also, if you have the same rows and columns in the first and second, if they are same, then you can do the multiplication of the matrix. Okay. So here AB matrix is there. No? AB product, we got this as the matrix. In that only question you may have like this. For the given matrix, we have to find the transpose of this one. So here, if find the product of the matrices A comma B, no? Also find if we have AB to the power of T. That is the transpose of the matrix. So able to see this. Find AB to the power of T means transpose of the matrix. Here, whatever the matrix we got, for this only we have to find the transpose of that one. AB to the power of T means what you will get? This as first row you should write as a column and second row you should write as a column. That is 2 minus 4 minus 3, next 1 minus 5, 3. Interchange of rows by columns. Okay. 2 minus 4 minus 3, 1 minus 5, 3. And now what we have the interchange. So order will also interchange. That is 3 by 2. 3 rows we got and 2 columns we got. So like this problem you will get for the 5 marks one. He will ask the product and also transpose of the product. So up till here you have to do the multiplication. After that, just whatever the rows are there, you convert the rows as a columns. That is only the transpose of the matrix. Okay. So if you have the example problems or in the exercise, if you have, you can do the same one. So one more same problem is there. It might be in MEQ, I think so, model examination question it is there. A and B is there. A is minus 1, minus 4, 5, 7, 3, 6. B is 2, minus 5, 3, 4, 11, minus 1. Here how many rows are there? 2. 2 by 3 rows. 3 by 2. Okay. So this also same, follow this rule. First condition is check the number of columns and number of rows. Okay. So next important one is scalar product of the matrix will be there. Scalar product means it is nothing but just you multiply the matrices with any number. If you multiply with any number, then we call it as a scalar product of the matrix. That is why you can take example as a, if your B is there, this is 2 by 2 matrix, 2 by 3 matrix now. If you are multiplying with K, K means each and every element you have to multiply with K. If 3B is asking in the examination, B is given, if B equals to this one, then find 3B. 3B means here, whatever 3 is there, you have to multiply this with whole matrices. Then you will get it as 3. 3 2s are 6, 3 3s are 9, 3 4s are 12, 3 5s are 15, 3 6s are 18. Okay, this is called as a scalar product. Scalar product means if you are multiplying with any number, then this number should be multiplied to each and every element. Okay, not only one row or not only one column. which should be multiplied with each and every element, that is called as a scalar product of a matrix. Okay. So 3x means just you multiply with all the elements. On this also one example problem you have in your textbook. So this concept also in some problems we'll use it. Next, the another one is, so multiplication also problems you see and practice from the textbook. If any example problems are given, so try to do the multiplication of that one. Next concept is very important for the solving the problems. It is the determinant of the matrix. Okay. So determinant of the matrix means modulus, like it will be there. Instead of this, we are putting here brackets. No? Instead of brackets, we put as a 2 lines. Then we call it as a determinant of the matrix. And here, determinant of the matrix will be different for 2 by 2 matrix and also 3 by 3 matrix. It's just a slight difference will be there. The concept for the 2 by 2 matrix and also 3 by 3 matrix. And even determinant of a matrix or inverse of a matrix will do only for the, that is the square matrices only. So for square matrices only, it is possible to find the determinant of the matrix or inverse of the matrix. Okay. Determinant of a matrix means will denote if any matrix A is there like this. A, B. I am taking only 2 by 2. First 2 by 2 we are seeing determinant of a matrix. Okay. So determinant of a matrix, if A is there, then A, B, C, D. A, B, C, D, any matrix. To find determinant means we'll write this modulus like this. This is called as det of A. Shortcut, det of A or determinant of A. Like this modulus if you write, then we have to write for the matrix also. A, B, C, D. Like this. Okay. So this is called as a determinant of the matrix. And determinant of this is 2 by 2 matrix. No? Determinant of 2 by 2 matrices is nothing but just you have to do the cross multiplication of these two. That is A into D. First these two you have to multiply. AD and minus of this one. That is minus of BC. First element and last element. After that second element and here first element. AD minus BC. This is the determinant of 2 by 2 matrices. Okay. So if you take any one like this, example. One minus 2, 3, 4. Okay. Then find determinant of A. So determinant of A means, so first determinant of A equals determinant of 1, 3, 4. Multiplication of 4 into 1 minus. Here already minus is there, but we have here this actually it is minus of no. So minus of minus 2 into 3. 4 minus of minus is plus 3 2s are 6. That means we got 10 here. Okay. So one more from here, one more definition is that if the determinant of a matrix, here you got value, no? So you got some value which is not equals to 0. Okay. This value is not equals to 0. Then such type of matrix is called as non-singular matrix. Non-singular matrix. Okay. When you are not getting the value as 0, then such type of matrix is called as non-singular matrix. Okay. So if we see one more for this only, if A equals to, we have 2, 3, 6, 9. Then determinant of A. So determinant of A is equals to determinant of 2, 3, 6, 9. So it is equals to 9 2s are 18. 9 2s are 18 minus 6 3s are also 18. No? So what we got? We got the value determinant of this value as 0. So whenever the determinant value you will get as 0, then it is called as singular matrix. Singular matrix. Okay. Singular matrix. And why I'm telling the concept of the non-singular means non-singular matrix, we can find the inverse. If a matrix is non-singular matrix, then only inverse of the matrix is possible. So no, that is compulsory. It should be not equals to 0. If it is not equals to 0, if it is equals to 0 means what will happen? We can't find the inverse of the matrix. Whenever you are getting the value as not equals to 0, simultaneously, even I am telling the exercise problems also. Okay, if you see whatever the problems are, I have told that are exercise problems only. Okay, once you check that one. So if A is there, if you are not, you are getting not equals to 0, then we call it as non-singular matrix. For a non-singular matrix, only remember, mark this line. Okay, for a non-singular matrix, only inverse is possible. Okay. For singular matrix, inverse is not possible. So that concept, you remember that one. Even singular matrix and non-singular matrix, you have the definitions in your textbook. So this is the 2 by 2 matrix now, for determinant for the 2 by 2 matrix. Now we'll see the determinant of 3 by 3 matrix. So determinant of 3 by 3 matrix means determinant, even it is possible only, remember that it is only possible for square matrix. Square matrix only we can find the determinant. So 2 by 2 means, remember this formula, that is AD minus BC. Okay. So here I have told inverse, no? Here we see even inverse also. Inverse also, inverse of a matrix. Okay, inverse of a matrix is first condition. It should be non-singular matrix. Then we can find the inverse of a matrix. Even inverse of a matrix will be for 2 by 2 matrix and also 3 by 3 matrix. Okay, for 2 by 2 matrix, you will have one formula. For 3 by 3 matrix, you will have another formula. How you have determinant for 2 by 2 and 3 by 3. Okay, so here we are talking about 2 by 2. That's why inverse of 2 by 2 matrix I will tell. Okay, inverse of 2 by 2 matrix means same here. A matrix will be given, any matrix. If A equals to this one, then find inverse of the matrix will be asked in the question. Okay, first thing is you will find the determinant. Determinant is should be not equals to 0. Why it should not be equals to 0 means A inverse formula is, it is equals to 1 by delta. Okay, 1 by delta into, here we have seen this now, A, B, C, D. That is D, here interchange will be there, D and A, and here minus B minus C. So this is the, for 2 by 2 matrix, this is the inverse formula. Okay, so for inverse of a matrix, that is 2 by 2, formula A inverse is 1 by determinant of A into, here what matrix will be there, no? That matrix just interchange this one. D will come here, A will come here. That is D, A, and for these two values, you will have the negative sign. Okay. So why it should be non-singular? If you will get here 0 means what will happen? 1 by 0. No. So this whole thing will vanish. 1 by 0 means you will get infinity. So you will not get any value. No. It will be undefined one. So that's why inverse is possible only for non-singular matrix. If it is a singular matrix means 1 by 0. So that's why inverse is possible only for the non-singular matrices only. Why? Because we'll write here the determinant value. Okay. So 2 by 2 matrix, you write this formula. This is the, if you know this formula for 2 by 2 matrix, we can find the inverse of a matrix. So problem, inverse of a matrix means, given exercise problem is there, find the inverse of Okay, find the inverse of A. Three minus 2, 5, 8. Okay. So first you check it is non-singular or not. Okay. So we need determinant. No, determinant is equals to 3 minus 2, 5, 8. So just cross multiplication. No, 3 8s are 24. Minus of minus is plus, 5 2s are 10. So we got here 34, which is not equals to 0. So hence A is non-singular. A inverse exists. That is inverse exists. Okay. Therefore, A inverse exists. So what we have A inverse equals to 1 by determinant. Determinant value is 34. 34 into this is dA. Just interchange this one. That is 8 and here 3. And here already minus is there. Minus of minus means it will become plus 2. And here it will become minus 5. So this is A inverse for 2 by 2 matrix. Now, if you want, you can keep like this only, or else we can multiply this one for all the elements. Then you will get 8 by 34, 2 by 34, minus 5 by 34, next 3 by 34. Okay. If you want, you can cancel out this. This is the 2 4s are 8, 2 1s are 1, 17. You will get this also 1 by 70, or else you can keep like this one. So if you want, you can simplify that if any cancellation is possible, or else you keep like this only. Okay. So if a 2 by 2 matrix is given, you have to apply this formula and we have to find the inverse of a matrix. Okay. Next, we'll go to the determinant of 3 by 3 matrix and also inverse of 3 by 3 matrix. So that's why first we have seen the 2 by 2. Now we'll see the 3 by 3 matrices. Okay. So for the determinant of 3 by 3 matrices, so this formula compulsory, you write that one. So before going to the 3 by 3 matrices, that is the determinant of 3 by 3 matrices, you should know the concept of the what is the minor of a matrix. Okay. Minor of a matrix means minor of a matrix. Okay. Minor of a matrix means if you take any matrix like this, capital A is equals to A1, B1, C1, A2, B2, C2, A3, B3, C3. So this is 3 by 3 matrix. Okay. So this is our 3 by 3 matrix. It has, there is 3 rows are there, 3 columns are there. So for the determinant of the matrix and also for the inverse of 3 by 3 matrix, we should know the concept of minor of a matrix. Okay. So minor of a matrix means if you eliminate, remember this is the first row, second row, and third row. This is the first column, second column, third column. And here we'll represent the rows as I, as the rows, and J as columns. Starting only I have told this one. Okay. I as the rows and J as the columns here. So here, so minor means if you eliminate any row and first row and here first column, then whatever the eliminates are remaining, that is called as a minor of a matrix. Okay. Obtained for a square matrix, the minor of element is defined as a determinant of the 2 by 2 matrix obtained after deleting the row and column in which the element is present. Okay. So here if you want to find a minor of A1, okay, How many elements are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. For 9 elements, we can find 9 minors. How? So if we'll take minor of A1. Minor of A1 means for this element, you are finding the minor. For that, you have to eliminate, means you have to take out this row and this column. If you take out this row and column, what is remaining? These elements are remaining. That is determinant of B2, C2, B3, C3. Okay. You have eliminated this column and this row. Only left is this one. If you take second one, that is same minor of B1. Minor of B1 is equals to this. It is present in the first row and it is present in the second column. If you take out this row and this column, what is left? A2, C2, A3, C3. That is A2, C2, A3, C3. Compulsory for minor, you have to write determinant only. Okay. So next, if you take out C1. So C1 means this row and this column. What is remaining? A2, B2, A3, B3. A2, B2, A3, B3. Okay. So for each and every element, here 9 elements are there. For 9 elements, we can find the 9 minors. If we take out second one, A2. A2 is equals to this column. Okay. This row. So now what we have? B1, C1, B3, C3. B1, C1, B3, C3. So this is the minor of A2. If we take B2. B2 means this column and this row. Then A1, C1, A3, C3. If B2. A1, C1, A3, C3. Okay. So like this, it will take even C2, this row, this column, then A1, B1, A3, B3. And if you take this third row, if you take out this element, this column and this row, B1, C1, B2, C2. Like this, for 9 elements, we can find the 9 minors. Okay. So these minors concept is important for finding the determinant of a matrix and also inverse of a matrix. Okay. So this is the concept of minor. For this only, we have the cofactor is there. Okay. Cofactor of a matrix means in this only cofactor of a matrix. Okay. Cofactor of a matrix is nothing but you will have the formula like this, that is minus 1 to the power of I plus j into minor of that one. So minor of any element you are finding means for that we have to find the here any minor element into minor. Okay, definition is the cofactor of an element in the ith row and jth column of a matrix is denoted as its minor multiplied into minus 1 of I plus j. I is the row and j is the column here and minus 1. Okay. So here we got for 1, 2, 3, like this 9. For 9 elements, we'll get 9 minors. Like that only for 9 elements, we'll get 9 cofactors. Simple. Whatever here minor of A is there, no? Instead of that, if I'll write cofactor of A. Cofactor of A. Cofactor of A is nothing but minus 1 to the power of I plus j. Formula is what? Minus 1 to the power of I plus j. Minus 1 to the power of I plus j into column this one. For this element, you are finding cofactor. So minus 1 to the power of I plus j into minor of that one. So this is equals to minus 1. Minus 1 into I means here row. So this element A1 is present in which row? This is present in first row. So that I value is 1 here. And next J. Which column it is present? It is present in the first column. So 1 plus 1. And this is 2 by 2 only, no? So you can do the multiplication of that one. B2 C3 minus C2B3. Okay. So now this simplification means here you may get the positive sign or negative sign. So for the minors only, if you have positive or negative sign, that elements are called as a cofactors. So for that only, minor and cofactor, they are interrelated to each other. Cofactor means just minus of I plus j into minor. So for each and every element, if you find the minus, they will have some positive signs and they will have some negative signs that are only called as a cofactors. So there is no lot of difference between these two. They are interrelated to each other. If you find the minus, then easily you can find the cofactors. Just the sign will be there. Values are same. These are only the minors. You may have for this minus sign, for this you will have positive sign, here negative sign, here positive, here negative, like this. Those are called as a cofactors. Okay. So here if you see minus 1 to the power of 2. So minus 1 whole square. Minus 1 whole square means what you'll have? You'll get a positive one. And already you know minus 1 of all the odd values. That is minus 1 of 1 equals to 1. Minus 1 of 3 equals to minus 1. Minus 1. And this is minus 1 to the power of 5 equals to minus 1. Minus 1 to the power of 7 equals to minus 1 unit. Okay. And if you have here, instead of odd, if you have the even values, that is square equals to 1, minus 1 to the power of 4 equals to 1, minus 1 to the power of 6 equals to 1. Even powers, you will get the positive values. Odd powers, you will get the negative values. So here, for all, if you for 9 elements, you will find the minors. What are cofactors? See first element. Here for you will get the positive value. Minus 1 square we got. So you will get the positive value. Here 2 we got. Here 3 you will get. Here 4, 5, 6, 7, 8, 9, 10. I am telling the powers here. Okay. Here 2, 3, 4, 5, 6, 7, 8, 9, 10. So in this you see which powers are the odd one. For that you put the negative sign. And for which powers are the even, you put for them positive powers. So if you see here, this we got, plus we got. So next you will get minus. Here next you will get plus. So plus, minus, plus. Here minus. Here you will get plus. And here minus. Next this is plus. This is minus. And this is plus. Okay. Why? Because this is to the power of 2, power of 3. Power of 3 means minus 1. Power of 4 means positive. This is 5 is there. So 5 means negative. 6 means positive. 7. 7 is the negative one. 8 and this is the 9. So 9 you will get again negative. And this is the 10 one. So even power, so you will get the positive value. So that is the difference between the minor and cofactor. For cofactor, again, no need of finding the values. If you find the minor, to that just add the sign. So no need of writing even these all. Just you remember here in the table itself, whatever the matrix you are getting, first only you put here, this has negative, this has negative, this has negative, and this has negative. So all other values are positive only. So these minors and these cofactors are important for finding the 3 by 3 determinant and 3 by 3 inverse. Okay. So I hope so you understood the concept of cofactor and also minor of a matrix. Okay. So here you write this one, this sign. These are important for finding the determinant of a matrix. Okay, now we'll see the determinant of 3 by 3 matrix. Determinant of 3 by 3 matrix means, so on this you have the problem, you have find the determinant of A. So matrix is 0, 1, minus 2, 1, 3, 2, minus 2, 2, 4. Okay, this is the given matrix. So for this matrix, we have to find the determinant. Okay, so this is the 3 by 3 matrix. You can write here 3 by 3. 3 rows are there, 3 columns are there. Now for finding determinant of A, okay. So if you understood the concept here, directly you can do the, first I'll tell direct method. Directly you can find the determinant. So if this concept you have not understood perfect, then you can just elaborate this solution and we can write this one, okay. So determinant is equals to, first thing here, first row, first element, no? First is 0, 0 into, so you have to eliminate this row and this column. So what is remaining? If you want, like this also you can write, okay, I'll tell that one second one. So 0, 0 into, if you eliminate this column and this row, 3 4s are 12, minus 2, 2 into 2 into 2. Okay. Next, this is minus 1 now. Why? Because your second element, you will get minus 1. Okay. So that's why you write this. Don't forget to write this symbol. If you don't write that one, means the answers they will be changing. Okay. So minus 1 into the second element, you will get as negative. So minus 1 into this column and this row. If you eliminate 1 into 4. Minus, here already minus is there. So you will do the minus now. So minus of minus means plus 2 into 2. So plus 2 into 2. Next here minus 2. Here in the given question it is there minus. But here actually we will get the positive sign only. So plus into minus means minus only. So minus 2 into this column and this row, if you eliminate 1 into 2. Here also negative sign is there. So you will get plus 2 into 3. Okay. So here we got 0 into this. So you can eliminate this one. This whole thing you will get as 0 value. So 0 into anything is 0. So first element value eliminate. Next what we have? Minus 1 into 4 into 1 is 4. Plus 2 2s are 4. Okay. Here minus 2 into 1 into 2 is 2 plus 3 2s are 6. So 4 plus 4 is 8. Minus 1 means minus 8. 6 plus 2 is 8. 8 minus 2 is minus 16. What we got? Minus 24. Okay. So this is minus 24 and this value is not equals to 0. So it is a non-singular matrix. So like this, we have to find the determinant of a matrix. This is the direct method. Means if you understood the concept of the finding the determinant directly here by taking the negative sign, and remember determinant of a 3 by 3 matrix means we'll find only for the first row. It's enough. Okay. First row, if you find the determinant, there is a cofactors. If you find, it's enough. When you go to the concept of the inverse of a 3 by 3 matrix, you have to find for each and every element, 9 elements, you have to find the 9 different cofactors. Okay. So that is the difference between determinant of a 3 by 3 matrix and inverse of a 3 by 3 matrix. This we have done directly. That is by eliminating first row, first column, and you have multiplied this one. So if you are not perfect with this concept, then you can write like this. That is a cofactor of for what we are finding, cofactor of 0. So cofactor of 0 is equals to, before I have told no that one, minus 1 to the power of, this is the first row, first element. So minus 1 to the power of 1 plus 1. And you eliminate the row and column, then you write the minor, that is 3, 2, 2, 4. So if you have any confusion in the direct method, then you write like this. And then you'll get the same answer both. That is minus 1 into 1 plus 1. If you eliminate that, this is the minor 3, 2, 2, 4. So minus 1 to the power of square means you will get here positive value. And if you do the determinant of this one, 3 4s are 12. 12 minus 4. So 12 minus 4 means you will get it as 8. Okay. So 3 4s are 12 minus 4. So you will get it as 8. This is the first zero value. Next is same cofactor of 1. Cofactor of 1 is equals to minus 1 to the power of. This 1 is in the first row but second column. So 1 plus 2. And what is the minor? If you eliminate this one and this one, 1, 2, minus 2. 1, 2, minus 2, 4. And here power you are getting as a 3. So odd power you are getting, it is minus 1. Minus 1 into, if you do cross multiplication of this one, 1 into 4, 4. Minus of minus is plus 4. So 4 plus 4 is 8. 8 into minus 1 means you will get minus 8. Okay. So this is the for cofactor of 1. Next, if you will go to the cofactor of next element is cofactor of 2. Cofactor of minus 2. So cofactor of minus 2 means this is the first row but third column. So minus 1 to the power of 1 plus 3 into what is the minor? 1, 3 minus 2, 2. So here you will get power as even power. So we will get plus sign into 2 plus 3 to the 6. It is 8, positive 8. Okay. So here also if you see, I have directly how we have done 0 into, you have eliminated the rows and column that multiplied directly. But you have any confusion here means you can do like this also. Okay. So if he's asking for the 5 marks question means you can follow this procedure. So just if you have any confusion here or here, both you compare that one which is easy for you to follow that and solve the problem. Okay. So here after getting all these values, so we need answer minus 24 now. Here we got each and every cofactor we got. Okay. So next determinant of A equals to, therefore det A is equals to sum of products of elements of the rows with their corresponding cofactors. That is 0. First we have no cofactor of 0. 0 into what we got answer for 0, 8 we got into 8 plus for 1 into we got the answer as minus 8. Okay. For next minus 2. We got here 8 answer. Okay. That is whatever for what value you are finding that into answer. 0 into 8, 1 into minus 8, minus 2 into 8. So this is minus 8 and this is minus 16 equals to minus 24. Same answer we got now. Here also minus 24. Here also minus 24. Okay. So determinant of a matrix, if you are perfect with the concept, directly you can find like this. If you have any confusion for some problems, you try this one. Why? Because for other concept also, inverse also, you have to follow the same procedure. So if you do this on cofactor of each and every element, it will be somewhat lengthy process. Directly if you will find also, you will get the answer. But the procedure is the same one. You will get the same answer only. Okay. This is the determinant of 3 by 3 matrix. Next, last concept in this is finding the inverse of a 3 by 3 matrix. Okay, 3 by 3 determinant we have seen. Now we'll see determinant of a inverse of a 3 by 3 matrix. Here, inverse is nothing but whatever the cofactors we are getting for the each and every element. So minor concept when I have told 9 elements, you will get the 9 different values. So if you see A1, B1, C1, A2, B2, C2, A3, B3, C3. Okay, this is if you think one matrix. If we find the determinant of this 3 by 3 matrix, only finding the cofactors of first row is enough. Okay, but when we find the inverse of this one, we have to find a 9 How many are there? 9 elements are there. For 9 elements, you have to find 9 cofactors. 9 cofactor means this is the cofactor value, 8 here. Here, before one we got here value, -8. That is a cofactor value. Means 9 different values you will get. You can represent them as like this capital A1, B1, C1, A2, B2, C2, A3, B3, C3. Okay, 9 different values you will get. Cofactor means for each and every element you are getting some value. If you write that value here, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 different values you will get here. Okay. If you write 9 different values here, and if you do the transpose, means one matrix is forming here. This is the given matrix. From the given matrix, when you find the cofactors, you will get one different matrix. This matrix, when you do the interchange of this one, you think this as a P is there. You got some one matrix P is there. You got these all cofactors. If you do the transpose of this one, transpose of P, that means A1, B1, C1, A2, B2, C2, and here A3, B3, C3. This is called as adjacent of matrix. Adjoint of the matrix. Adjoint of the matrix. Determinant concept is interrelated with this one. That is set A. For set A, you are finding all the cofactors. The cofactors when you write in one matrix, and if you do the interchange of that one, that means transpose of that matrix is called as the adjoint of a matrix. So why we are studying about the adjoint of a matrix means for the inverse of 3 by 3 matrix, we have different formula is there. Okay. So 3 by 3 inverse is A inverse is equals to adjoint of A by determinant of A. This is the formula. Okay. A inverse of 3 by 3 matrix. Okay. A inverse is equals to adjoint of A by determinant of A. Adjoint means this one. Determinant means first we have found now 3 by 3 matrix determinant. Whatever that value you will get here, we got -24. So -24 of adjoint of A. If we do the simplification of this one, this is the inverse of the 3 by 3 matrix. Okay. So don't get confused about this concept. If you understand once directly, if you saw the problems, you will understand the concept very easily. So we'll see one problem on inverse of a matrix. So if you'll see the exercise problems, all simple problems are there. First one is the find the order of the matrix. Next one is the find two matrices are given, find A plus B. Third one is X is given, find 3X. Just you have to multiply with the 3. And fourth question is A and B are given, find the product of those matrices. I have told these example problems. Fifth one, A and B matrices are given. He is asking to find AB whole transpose. That is first find the multiplication of that one. Then you find the transpose of that one. Next, find the determinant of only 2 by 2 matrix is given and is asking to find the determinant of that one. Okay. So next we have the concept of the inverse of the matrix. So inverse of the matrix means for each and every element you have to find the cofactors. Actually in your textbook one problem is there, that is for that you are getting very lengthy values, very big values you are getting as the cofactors. So that problem, whatever the values they are given, they have given somewhat different ones. Okay. So if A equals to 2, 10, 9, -4, 3, 6, 11, -12, 10. So they have given these all very big values. That's why you are getting the answers as large numbers you are getting. Okay, 3 by 3 matrix, 3 by 3 matrix it is. So find the inverse, or then find A inverse is enough. Okay, first condition for A inverse is that we have to find the determinant of this one. And it should be non-singular. If it is non-singular, then only we can find the inverse. So determinant of this one is 2 into 3 into 10 plus 12 into 6. Next, second element is minus 1. So minus 10 into 10 into minus 4, that is minus 40. This column and this row. So 10 into minus 4 minus 11, 6 are 66. Next, plus 9 into minus is plus 12, 4 are 48. Minus 11, 3 are 33. 2 is into 10, 3 are 30 plus 6 are 12, 172 is. And this is minus 10 into, this is minus of minus. Minus how much? 10. So 106. And plus 9 into 48 minus 33. So we'll get 15, no? Plus 15. 15 into 9. Okay. Now this is 102. 102 into 2. Means 204. Minus into minus. This is plus 10, 0, 6, 0. Next, this is plus. So 15 9s are 135. So all we got positive values. 9.5 minus this is plus 10 0 6 0 2 0 4 1 3 5 9 9 1399. So this is not equals to 0. Okay. So this is not equals to 0 means it is non-singular. So therefore, here you write since det A is equals to, since determinant of A is not equals to 0, A is non-singular and therefore A inverse exists. Okay. So first condition is this one, and now we have to find the cofactors of these all elements. So cofactors of each and every element means cofactor of first one, cofactor of 2. So 2 means minus 1 to the power of 1 plus 1. And determinant of, for first element I am writing determinant 3, 6 minus 12, 10. Okay. So this is the positive value, 2 we are getting. So 10 3s are 30, minus of minus 72, you will get 102. Okay. Next, cofactor of 10. Cofactor of 10 is equals to minus 1 to the power of 1 plus 2. Next, if you take out these two, minus 4, 6, 11, 10. Okay. So this is negative value. And this is minus 40, minus 66. So minus 106 plus 106. So like this, for each and every element, you have to find the cofactor. Next, cofactor of 9. Okay. I am writing direct answers. Try to solve them. Okay. Cofactor of 9 you will get as 15. Next to cofactor of minus 4. This element minus 4 means is 1, 2, 3. And this is 4 you will get. That means 5. So already negative is there. So we'll get here negative sign. And the answer is minus 208. Okay. Next, cofactor of 3. Don't get confused. Cofactor of 3 means this is in the second row and second column. That is minus 1 to the power of 2 plus 2. And what you will get? 2, 9, 11, 10. Okay. So this is the, and the answer is minus 79. Minus 79. Okay. This is 2 tens are 20 minus 99. That's why I got here minus sign 79. Next, cofactor of 6 is, cofactor of 6 is 134. Okay. Next, cofactor of 11 is 33. Next, cofactor of minus 12 is, same procedure you have to follow. Okay. If you have any doubt about this, tomorrow you can ask. Minus 48. Next, cofactor of 10. Cofactor of 10 means you will get 46. Okay. So we got here, see, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 values we got. Okay. 9 cofactors of the different elements of the given matrix. Now, what is the adjoint of the matrix? Here you can write cofactor of A is equals to, cofactors of this A equals to B. We are taking another matrix. It has, what is the first value we got? We got 102. Okay. Second value is 106. Next, third value is here 15. Next, fourth value minus 208, minus 79. Next, 134. Next, 33, minus 48, 46. Okay. Like this, each and every cofactor you have to write in the matrix. First element, second, third, fourth, fifth, sixth, seventh, eighth, ninth. Okay. This is the cofactors of A. We are calling it as one matrix. That matrix is B. Okay. So then adjoint of A is equals to transpose of this one. That is B transpose. B transpose means just interchange of the rows by columns. That is 102, 106, 15, minus 208, minus 79, 134, 33, minus 48, 46. So we got adjoint of A. What is A inverse formula? A inverse is equals to adjoint of A by determinant of A. Okay. So adjoint of matrix we got, and even determinant value also we got. Starting how much? That is 1399. So it is equals to 1 by determinant. Our value is 1399 of this one. That is 102, minus 208, 33, 106, minus 79, minus 48, 15, 134, 46. Okay. If you want, you can keep like this only, or else for each and every element. Before one we have done, no? For each and every element, you divide with this one. That is 102 by 1399 minus 208 by 1399, like this. Or else keep like this one. Okay. So this is the inverse of a 3 by 3 matrix, and this finding the cofactors are adjoint of the matrix. You will get for the 10 marks question in the section B. Adjoint, just he will ask to find adjoint of a matrix or find the inverse of a matrix. So determine whatever the concept is there, that is you will get for only 5 marks question, but the 10 marks question are this finding the inverse or finding only adjoint of A. Adjoint of A also up till here no concept. Okay. So this is 10 marks question and this is the 10 marks question. Remaining whatever the questions are there in the textbook, that all are the 5 marks question. These two are the 10 marks questions. And here next step you write this whatever it is there, you divide that one And if any cancellation is there, 102 divided by 1399. If with any factors it will go, just cancel out that one. Or else you can keep like this only up till here. So this is the concept of the inverse of a matrix for the 3 by 3 matrix. Okay. So by this we are completing the matrices. So tomorrow we'll see the differential calculus and also integral calculus concepts. In that some before coming to the class, try to see all the standard functions formulas are there, no differentiation formulas. There is d by dx of sin x, cos x, tan x, secant square x, and cosecant x, and inverse also there. In your textbook, formulas are there. So for all those functions, once you see all the formulas, and just to remember that if you know the formulas only, then only we can solve the differential calculus problems. Okay, students. So this, whatever the answers we have got here, just you check that one. You will see one and 2, 3 problems are there regarding of the adjoint of the matrix and also inverse of the matrix. Example problems are there in your textbook. One exercise problem is there. That is 3, 6, 9, minus 2, minus 4, minus 6, 5, 10, 15. Matrix is given in the question. You will see, if you have the textbook, you can see that one. So for this, you will get all the values as zeros. Means each and every element cofactor you will get as 0, 0, 0. That means you will get the adjoint of the matrix as the zero matrix you will get. So if you have time today, try to solve that one and check whether you are getting the zeros or not. That is exercise problem you have, find the adjoint of the matrix. Okay. So tomorrow we'll see the differential calculus. Yes, what doubt you have, Suresh Kumar? Okay, tomorrow we'll see the class.